Okay everyone, we're going to look at areas under curves and we're going to start by looking at easy ones. Okay, a typical C2 question will ask you to find the area bound by the curve. In this case, y equals x squared plus 2. A couple of lines, this case x equals 1, x equals 5, and the x-axis. So the first thing we're going to do is we're going to do a sketch. Okay, now I'm going to slightly exaggerate this, but y equals x squared plus 2 looks a bit like that. Obviously it cuts at 2. And the line's x equals 1, there's x equals 1, here x equals 1, and here x equals 5. They're supposed to be straight actually, so let's make them look a bit more straight. Okay, x equals 1 and x equals 5. So the area that we're wanting is this area in here. Okay, we're wanting it bound by the curve, the line x equals 1, the line x equals 5, and the x-axis. Okay, so how do we find the area between a curve and an x-axis? We do this. We integrate the curve, that's y, with respect to x between two limits, b and a, where this is the first limit and this is the second limit. Now, you haven't seen that before. You can either just trust me on it and work with it, or if you want to know where it comes from, have a little look on the website, and I've got a couple of videos up there where you can click and understand where it comes from. It's actually called the Fundamental Theorem of Calculus. All right, they're worth a watch. Okay, so the area is found by integrating the curve. So the area is going to be found by integrating my y, which is x squared plus 2, between these two limits. Now notice, this top limit is always the limit on the right. So the top limit goes on the right, so I'm going to put the 5 here, and the bottom limit, this bottom limit, is going down here on the bottom. All right, so that's the right is on the top, and this one, the bottom limit, is the limit that is furthest to the left. All right, and it's important we get them the right way round. And what we're going to do, we're going to integrate it with respect to x. Now, you've just been doing these in the last video, so you should be absolutely 100% perfect about these. Okay, let's see if I can get a bit of space. Let's move him up. So I've got a bit of space. Okay, so the area is x squared plus 2. So we're going to integrate x squared plus 2. I'm just going to set it up so that I can integrate it nicely. There's a 1 in there, in. Okay, so remember guys, square bracket, square dog. So it's going 1 bracket bracket x plus 2 bracket bracket x and square dog, and the limits 5 and 1 are coming over to the side. And add 1 to the power gives me 3 and flip it. Add 1 to the power gives me 1 and flip it. And into the square dog is going a third x cubed, I'm just going to neaten it up, plus 2 lots of x to the 1 bracket 5 1. Okay, so now going out of the dog into the square, into the, not the square, into the curly brackets, I'm going to go a third times 5 is going to go in first. All right, so the 5 is going to go in first. 5 cubed plus 2 lots of 5, big bracket. Now I'm going to feed the 1 in. So the 1 is going to go a third 1 cubed plus 2 lots of 1, bracket, bracket. And don't forget our little trick that when we did 5, we would have found the area all the way up to 5, but we want to take off that little area up to 1. Okay, so there's a big subtraction sign in the middle. Okay, so let's neaten that up. Okay, 5 cubed is 125, so 125 over 3. Plus 2 5s are 10, that's the first bracket, minus 1 cubed is 1, so that's a third plus 2. Okay, so I'm getting the first one out as 155 over 3, that's the first bracket, minus 2 and a third, which will give me, I think it comes to 148 over 3. Okay, done. Okay, this is a slightly different question. I want to find the shaded area. So I know that the area of my curve is the integral of y, that's the curve, with respect to x between two limits. And I might sometimes have to do a little bit of work to find the limits. Now I know one of the limits, all right, one of the limits is here, it's x equals 0. And there's also another limit here. And the first little bit we've got to do is we've got to find that limit. So I've actually got to find out what a is. Okay, I don't know what he is at the moment. Now, just use what you know already. How do you find where a curve cuts an x-axis? It cuts an x-axis when y is 0. So when y is 0, we're going to get 0 equals 3 over 2 x squared minus a quarter x cubed. I'm going to times up by 4, I think that's probably the most sensible. 0 equals 6x squared minus x cubed, and now it will factorise nicely, x squared, that's going to give me 6 minus x. So it cuts the x-axis when x squared is 0, that's a double root, isn't it? X equals 0, that's that bit there, that's that double root sitting on the axis, or when x equals 6. So actually what we've discovered is that this line is 6. So I want to find the area. We're going to put the one on the right at the top, or the biggest one at the top, and the smallest one, or the one on the left at the bottom. And therefore I now have got the area bound between the curve, there's my curve, the lines, there's my lines, and the x-axis. So it will give me all of this curve here. Okay, so now off I go. The integral of y. So we're going to do the integral of 3 over 2 x squared minus a quarter x cubed, and it's the integral between 6 and 0. So I'm going to just set myself up nicely. Here comes my big square bracket. 3 over 2 bracket bracket x minus a quarter bracket bracket x, and the 6 and the 0 are going to fling over. Add 1 to the power gives me 3 and flip it. Add 1 to the power gives me 4 and flip it, and now I'm going to neaten it up. Okay, 3 times 1 is 3, 2 times 3 is 6, so in fact that will neaten up to a half. Let's make that a half, that will be better. So a half x cubed minus a 16th, 1 times 1, 4 times 4, x to the 4, and then 6 and 0. Okay, let's make him a bit smaller, give me a bit of room. So we're going to now feed in the 6. All right, so the 6 is going to go in. So we're going to go into my little curly bracket. A half 6 cubed minus a 16th 6 to the 4. And here goes my 0 going in. A half 0 cubed minus a 16th 0 to the 4. And of course they're subtracting. Okay, so into the first one. Is going 6 cubed then times a half is 108. 6 to the 4 then divided by 16 is 81. So that's going into my first. And phew, the whole of that one is 0. Okay, so then the answer is 27. Yeah, you've got to be quite careful on this question, because what I'm hoping you've noticed is that the area is split between a little portion here which is above the x-axis. Let's call that area A. And then a little portion here that is below the x-axis, and let's call that bit B. So if you notice that the area is split above and below the x-axis, you're going to have to use this split approach yourself. So we are going to do this in 2 parts. We're going to find the area of part A, and we're going to find the area of part B, and we're going to add them together. And eventually, as we're going, you'll realise why I've got to do it. Now, notice that the curve is x, x minus 1, x minus 5. So before we start integrating, we're going to have to do a little bit of neatening up. It's going to go x squared minus 6x, isn't it, plus 5. And therefore y equals x cubed minus 6x squared plus 5x. So that's what my curve looks like. So let's start off with, let's see if I can make him a bit smaller. Oh, I can make it all a bit smaller. Let's whiz it along. Let's whiz it down like that. There you go. That's perfect. Okay, loads of space. Right, so let's start off with area A. So area A is found by integrating the curve with respect to x, and the limits for area A, let's get him back, were 1 and 0. So we're going to integrate him between 1 and 0. Okay, so 1 and 0. So we're going to integrate x cubed minus 6x squared plus 5x, and we're going to integrate it between 1 and 0. Okay, so there's a 1 there. Let's put my little arrows in. Because my little arrows into the big square dog. So we're going 1 bracket bracket x minus 6 bracket bracket x plus 5 bracket bracket x, square dog, limit 1 and 0. Add 1 to the power is 4, makes a quarter. Add 1 is 3, flip it. Add 1 is... oh, I'm struggling on that. It's 2, isn't it? Goodness me. Brain gone dead. Okay, so then let's neaten it up. It's going 1/4 x to the 4 minus 2x cubed plus 5 over 2x squared into the dog 1, 0. Okay, so now the ones are going in. 1/4 1 to the 4 minus 2 1 cubed plus 5 over 2 1 squared. And now the zeros go in, so we're going to get 1/4 0 to the 4 minus 2 lots of 0 cubed plus 5 over 2 0 squared. There's a squared in there. Okay, with a big bracket. And don't forget, we are minusing the 2 brackets. Okay, so the first bracket comes to 1/4 minus 8 over 4 plus 10 over 4. And the second bracket is really tempted not to write that line. It's really tempting because you can see they're zeros. But please force yourself to write it in because it shows the examiner you know the method. Equals altogether 3/4. Okay, so let's move him over. He's area A. All right, let's stick him up there. And now what we'll do is we'll do the same for area B. Okay, so area B, that's the one underneath the axis, is the integral of y dx. Now, luckily, I've already done the integral, so I can skip. In fact, before I skip, let's have a look at my limits. So my limits for area B were between 2 and 1, weren't they? So you just double check those. They're between 2 and 1. So in there is a 2 and a 1. So it's the integral of y, which is x cubed minus 6x squared plus 5x, between 2 and 1, and integrating with respect to x. Now all I'm doing, gang, is I'm just copying it down because I've already done the integral. Is there. Can you see him? 1/4 x to the 4 minus 2x cubed plus 5 over 2x squared, but this time I'm doing it between 2 and 1. Right, let's drop the 2's in. 1/4 2 to the 4 minus 2 lots of 2 cubed plus 5 over 2, 2 squared, big bracket. Let's drop the 1's in. 1/4 1 to the 4 minus 2 lots of 1 cubed plus 5 over 2, 1 squared. I don't want to do that squared, does he there? And a big minus in the middle. Okay, so let's neaten all this up. Okay, 2 to the power of 4 divided by 4 is 4. 2 cubed times 2 is 16, and 2 squared is 4 times that gives you 10. All right, that's the first bracket. The second bracket is coming to 1/4 minus 2 plus 5 over 2, which I think is giving us 10 take away 6 minus 6, I think it's giving us 2. And the second bracket, I think, is coming out as minus 3/4. And so, sorry, not minus 3/4. It's a plus 3/4 there, isn't it? The second bracket. And therefore, it's coming out as minus 11 over 4. Okay, let's just move him up. And what I'm going to do is I'm going to bring the graph back. Okay, so what we've got here now is that the area of A is coming out as 3/4. That's that bit there. But the area underneath is coming out as minus 11 over 4. It's coming out as a negative area. Now, the reason that they're coming out as a negative area is to do with the proof videos. So if you've watched any of the proof videos, you'll know. Now, if we've got areas above and below the curve, what they're doing in the videos, in the proof videos, is they are summing a series of shapes. Now, sometimes they're a series of little trapeziums, or sometimes they're a series of rectangles. All right, and what they're interested in, whether they are trapeziums or rectangles, is they are interested in finding the areas of those shapes and adding them together, and therefore they're interested in the height. Now, if the area is above the x-axis, the height is a positive number. Hence, areas above x-axis come out with positive areas. But of course, if the area is below the x-axis, and I'm looking at trapeziums or I'm looking at rectangles, the height is now a negative height. So that's why areas below x-axis come out as negative heights. So all we do is we knew it was going to be negative because it was below. So actually, physically, the area of B is just 11 over 4. We just ignore the fact that it's negative. So the total area is going to be the area of A plus the area of B. And the area of A is 3/4. The area of B, we take the positive area, and therefore the total area is 14 over 4. Okay, some silly people do this. you're not going to do this, all right? Do not do this. They miss the fact that the area is split between a bit above and a bit below, and they think that they can just integrate the whole damn lot, okay, between 2 and 0. And I'll tell you the answer they get this. Well, that area is 3/4, and it gets put together with this area, but they put it together with a minus 11/4. So 3/4 add minus 11/4 gives us minus 8/4, and their calculator tells them that the whole answer is -2, which is rubbish. So what happens if you forget to split it into two areas is it will take the minus 11/4 as minus 11/4. So can you just be really careful that you remember, oh, that's clever, she's gone behind, you remember to do that split, okay?